Crash Course on Decision Tree, DT, Classifier for Business Analytics. Decision Tree, DT, Classifier is a powerful and intuitive algorithm used for classification and regression tasks in business analytics. It is widely used due to its interpretability and ability to handle both numerical and categorical data. In this crash course, we will explore the DT algorithm, learn how to construct a DT, discuss its pros and cons, and use it to predict customer churn based on the Telco Customer Churn dataset. Decision Tree Algorithm. The DT algorithm follows a tree-like structure, where each internal node represents a feature or attribute, each branch represents a decision rule, and each leaf node represents a class or a prediction. The algorithm recursively partitions the data based on the selected attributes until it reaches a stopping criterion, creating a tree that can be used for classification or regression. Constructing a decision tree. To construct a DT, follow these steps. A. Select a suitable attribute as the root node based on a criterion like information gain or Gini impurity. B. Split the data based on the selected attribute and create child nodes. C. Repeat the above steps for each child node until a stopping criterion is met, e.g., reaching a maximum depth, minimum number of samples. To construct a decision tree, DT, information gain, IG, theory and entropy play a crucial role. Information gain is a measure used in decision tree algorithms to evaluate the importance of a feature or attribute in the process of classifying data. It quantifies the reduction in entropy achieved by partitioning the data based on a specific attribute. The attribute that results in the highest information gain is selected as the splitting criterion at each node of the decision tree. Entropy is a concept borrowed from information theory and is used to measure the impurity or randomness in a set of data. In the context of a decision tree, entropy represents the degree of uncertainty or the diversity of classes in a given dataset. A dataset with high entropy contains a mix of different class labels, while a dataset with low entropy contains mostly homogeneous class labels. Entropy, S, equals sigma, p underscore I log 2, p underscore I. Where S represents the dataset, p underscore I represents the proportion of samples belonging to class I in the dataset, and the summation is performed over all classes. The entropy value lies between 0 and 1. A value of 0 indicates a completely pure dataset, where all samples belong to the same class. A value of 1 indicates maximum impurity, where the dataset contains an equal number of samples from different classes. Pros of decision tree. Plus easy to understand and interpret, decision trees provide clear and intuitive rules for decision making. Plus handle both categorical and numerical data. DT can handle a mix of data types without requiring extensive preprocessing. Plus handle missing values and outliers. Decision trees can handle missing values and outliers effectively. Plus nonlinear relationships. DT can capture nonlinear relationships between variables. Plus feature selection. Decision trees inherently perform feature selection by considering the most informative attributes. Cons of decision tree. Overfitting. Decision trees are prone to overfitting when the tree becomes too complex and specific to the training data. Instability. Small changes in the data can lead to significant changes in the resulting tree structure. Lack of global optimality. Decision trees make local decisions at each node, which may not lead to the globally optimal solution. Now, let's delve into some interesting stories and examples to excite our readers about the applications of decision trees in business analytics. Loan approval. A bank wants to automate its loan approval process. By using a decision tree model trained on historical loan data, the bank can make predictions on new loan applications. The model considers various attributes such as income, credit score, and employment history to classify whether an applicant is likely to default or not. Customer lifetime value, CLV, prediction. A telecom company aims to estimate the lifetime value of its customers to optimize its marketing and retention strategies. By analyzing customer demographics, purchase history, and service usage patterns, a decision tree model can predict the potential revenue each customer will generate over their lifetime. Disease diagnosis. A healthcare provider wants to assist doctors in diagnosing diseases more accurately. By utilizing a decision tree model trained on patient data, symptoms, and medical history, the system can suggest possible diseases based on the observed symptoms, helping doctors make more informed decisions. Fraud detection. A credit card company aims to detect fraudulent transactions in real time. By analyzing transactional data, customer behavior, and other relevant factors, a decision tree model can identify suspicious patterns and flag potential fraudulent activities, enabling timely intervention and fraud prevention. Customer segmentation. A retail company seeks to understand its customer base better for targeted marketing campaigns. By clustering customers based on attributes like purchasing behavior, demographics, and preferences, a decision tree model can segment customers into distinct groups, allowing tailored marketing strategies for each segment. Product recommendation. An e-commerce platform wants to personalize product recommendations for its users. By analyzing historical purchase data, browsing behavior, and customer preferences, a decision tree model can suggest relevant products to customers, enhancing the user experience and driving sales. Demand forecasting. A manufacturing company desires accurate demand forecasting to optimize inventory management. By considering factors like historical sales, pricing, promotions, and seasonality, a decision tree model can predict future demand for different products, helping the company make informed decisions about production and supply chain management. Credit scoring. A financial institution wants to assess the creditworthiness of loan applicants. By analyzing attributes like income, credit history, employment status, and demographic information, a decision tree model can classify applicants into different risk categories, enabling the institution to make informed decisions about loan approvals and interest rates. Employee attrition prediction. A company aims to identify employees who are likely to leave the organization. By analyzing employee demographics, performance, job satisfaction, and other factors, a decision tree model can predict the likelihood of attrition, allowing the company to implement targeted retention strategies and reduce turnover. Predictive maintenance. A manufacturing company seeks to predict equipment failures and schedule maintenance proactively. By analyzing sensor data, historical maintenance records, and environmental factors, a decision tree model can identify patterns indicating potential equipment failures, enabling timely maintenance and reducing downtime. In conclusion, decision trees are a fundamental and versatile tool in the field of business analytics. They provide a framework for decision-making, enabling businesses to leverage data and extract meaningful insights. Whether it's predicting customer behavior, optimizing operations, or identifying market trends, decision trees are a valuable asset for businesses looking to harness the power of data. Poem. In the realm of business analytics, we find a classifier with a structure so refined. Decision tree, its name echoes through. A path to insights, both old and new. With branches extending, like nature's design. It unravels patterns, so divine. Rooted in data, it grows and learns. From features and attributes, it discerns. Each node a choice, a question to ask. Guiding us on a decision-making task. Attributes explored, branching paths unfold. Leading us to knowledge, precious as gold. Oh, decision tree, a forest of decision. An algorithmic marvel, a business precision. From loan approvals to customer churn. You navigate complexities, a lesson to learn. Fraud detection, a battlefield so vast. You stand guard, the first and last. Uncovering anomalies, patterns so sly. Protecting businesses, as time flies by. Customer segmentation, a tapestry you weave. Dividing them into clusters, so they believe. Tailored strategies for each unique group. A personalized touch, a marketing loop. Decision tree, a guardian of insight. In the world of business, you shine so bright. With your algorithmic branches, you show the way. Guiding businesses to success, day by day. *****. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html $aid equals 7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our AnHub Metaverse channel, and please watch more interesting videos here.